Okay, so the way this pyramid construction works is so these are just showing you neighboring pixels. And even though this is like just one row, but you will have a full two-dimensional space for that. Okay, so just consider like one row of your image, which will be consecutive pixels. So, and this is just showing one dimension. So you will use your Gaussian filter, which is something like this, right? You will pay more attention to the center pixel and less attention to the nearby pixels. And then that's going to give you this pixel. So it's kind of average of all these. So this is your first like one scale of your Gaussian pyramid, and this is the next level. So in this case, you can see that whatever value you were getting for this one, you just skip that. So you are just alternating between pixel values. So you are reducing the resolution. So you perform filtering, you perform subsampling, skip those pixels, and you keep doing that. Okay. Again, if you do like Gaussian filtering of this, again, you are considering all these pixel values to compute this one, but again, you skip in between. Okay, it's just making sure that if some pixels have important or salient features, they are not skipped over. And again, this is one dimensional, you can easily generalize to two-dimensional space as well. Now, if you think about this, the total amount of memory you require to store like this Gaussian pyramid, it's not that huge. Even though if you have like a lot of layers, let's say 3-level or 4-level pyramid, it won't be a lot, because let's say if this is saving n pixels, this is just going to be n by 2 pixels. Okay, so for a 3-level, you will see like it's just like 4 by 3 of the size of the original image. So in terms of memory consumption, it's not increasing your memory consumption by a lot. Definitely, it's never going to go to like 2x. Okay, so now the issue with like that kind of approach will be, since we are looking at this specific aspect ratio, you might have individuals in your images, something like this. Right? There will be all sort of variations out there in real world. So whatever you do, but if you have this kind of window, it doesn't matter how many scales you use, you are always going to miss these kind of detections. Okay, but again, that's just one challenge. And of course, you can try to do maybe different aspect ratios, but again, that will just increase like the computational complexity. And whatever you do with one set of aspect ratio, you will have to repeat that with a lot of other aspect ratios. And we will see later on, like in the actual CNN algorithm, how this is being addressed.